In this session today, I'm going to talk about a brief overview of Fabric platform itself. That is the SaaS platform, how it is built, and how we are authenticating in Fabric. What are the various network protections that we have, and some of the ways of securing your data in Fabric. We'll talk about encryption and various access control mechanisms, and then we'll also touch base on some of the related concepts of security, such as residency, governance, and compliance. So in this session, you will get an overview of end-to-end security posture of Microsoft Fabric. So today, we are living in a world awash with data, and every business wants to translate this data into a competitive advantage. And if we look at the 2023 AI/ML data landscape, we had so many different tools to pick and choose that can do each different things. For example, you have to pick and choose a tool for ETL, a tool for ML, a tool for analytics, a tool for visualization, and so on and so forth, right? So the landscape was very complicated. There is a lot of integration needed. That's why every chief data officer that we interviewed, they have to say that, hey, I don't want to be the chief integration officer. I want to be the chief data officer. This was one principle behind why we built out a product like Microsoft Fabric, right? So our vision of Microsoft Fabric is to build a complete analytics platform, right? Um, that is a unified product where we are bringing all the experiences that are inherent to analytics, such as data integration, data engineering, data warehousing, visualizations, AI, ML, everything into one umbrella, into one product, so that they don't have to go and put these things together. That's one of the fundamental principles of building everything into one SaaS platform. And it is also built with lake-centric and open concept, which means that all the underlying engines, experiences that we see in Fabric are now storing and processing the data under a central storage, which is we call one lake. And we have also standardized on the format to delta parquet format. So all the engines are now able to understand the delta parquet format and write in delta parquet format so that it can be interchangeably used among different experiences, right? Um, and one of the key things to note in Microsoft Fabric is all these experiences are seamlessly interconnected with each other, unlike the individual products that we have to procure and provision and manage and secure and govern independently, right? So that's why we see that these are the four significant pillars of Fabric. It's a complete analytical platform. It has all the experiences that are needed to build an analytical solution. It is lake-centric and open because all the data is centrally stored, so it's easy to manage and govern and secure the one central storage. And it is built in a way to empower every user, that is, every Office user. As we know, Fabric is built on Power BI. It is tightly integrated with every Office experience, such as Excel, Word, PowerPoint, etc. So it's familiar and intuitive for the Excel users and PowerPoint users and Office users to use this Fabric with a familiar set of tools and concepts. And the last pillar is the pervasive security and the governance. Now we have all the engines under one umbrella, and the data is also stored in one lake. It is easier to manage, to bring all your security into this one single classified layer. Unlike, you don't have to go and secure each and every storage accounts, each and every databases, each and every independent resources. Instead, we will focus our security on one single umbrella, and then you get the benefits of all the other engines in one shot, right? And if you look at some of the modern data challenges across the organizations, is every organization wants to bring data to the masses, right? So they want to empower their end users, their business users in the organization. They want instant access to the data, right? um, uh, um, so what they don't want is, they don't want people to move or copy around to the data, right? But they do not want to compromise. At the same time, they don't want to compromise on the security and the governance aspect of the product itself, right? So SaaS platforms such as Microsoft Fabric, SharePoint Online, Teams, OneDrive, OneLake are built with these design challenges in mind. right? It is a shift. It's a paradigm shift from a siloed PaaS platform such as independent individual databases and storage accounts to a unified central data lake across the organization, where every users in your organizations are going to access the one single data lake across the multiple business units, right? So how do we ensure security in such kind of a concept, right? We're going to talk about it more on that. And especially when it comes to network security, this is the most requested features of all the enterprises, right? Every enterprise organization, they want to be able to connect to their data from that are sitting behind their firewalls and private endpoints. They want Fabric to connect to that data using private endpoints behind the firewalls and so on. They want to bring the data into Fabric securely and privately, right? And they also want to protect how users are authenticating to Fabric. They want to protect the inbound protection to Fabric itself. And they want to protect the backend services. Typically, the databases and the storage accounts are called backend services. That has been considered that way for so long. So they want to protect the backend services. And there are more stringent customers who care more about security, such as financial and healthcare customers who are obsessed with security. They want all their traffic to go via private, and they should not be traversed over the public internet, and all the endpoints should not be open to the public internet. These are some of the common themes that we hear across the organizations, right? Some of the common network security requirements that we see, right? And if you look at the existing password here, right? Um, then it's if you look at the existing world, how we used to do things in the past, right? If you look at the left, we have the data sources. We have the data sources sitting in on premises or other cloud resources behind firewalls, right? We used to put self-hosted integration runtime that are agents that can connect to these data sources behind firewalls and physically copy the data from on premises and other cloud sources and land it into storage accounts that we have to provision separately and manage separately, right? We use orchestration tools and pipeline tools such as Azure Data Factory that we have to individually provision, secure, manage to perform these data transfers from multiple data sources into storage accounts. And when the data lands into the storage accounts, storage account is just that. It's a storage, right? It can't do anything much more than that, right? It is not intuitive enough to know more about the data and give you analytical results, right? That simply storing the data itself is not going to help much of the business. So we need to run analytics on top of it, right? That's why we had to bring in analytical tools such as Synapse, and data warehouses, like the serverless databases, the Synapse Spark engines. We have to bring in other additional compute engines on top of it to perform analytics on top of this data, to model this data, to transform this data into a meaningful way, right? For that, we have to procure additional resources such as Synapse and additionally secure, manage, and govern Synapse resources separately. And if you look at the architecture of these things, ADF was a separate product that is completely independent from storage. Storage is a separate product which is completely independent from Synapse. All these services cannot talk to each other. They cannot seamlessly see each other's data, which means that the data stored in the ADLS cannot be seamlessly be connected from Synapse. We have to again copy this data into Synapse using Polybase or the other methods into data warehouses and then perform all the transformations on the SQL in data warehouse, or you have to perform the transformations over Spark, etc. Again, the storage accounts are logged from public consumptions from the public internet, and we expose private endpoints for these data developers to connect to these storage accounts. And same thing that we used to do with Synapse too. We block public internet access to the Synapse endpoints, and we allow these data engineers and data developers to connect to the private endpoints of the Synapse. And the Synapse has to be connected to the storage account separately, and all the data has to be authenticated and transferred into Synapse. So there's a multiple copies of data moving around. It's just not that, right? The data sitting in analytical engine is again not going to be useful to the large volumes of business users. They want to do reports, they want to get reports out of it, they want to get dashboards out of it, they want to get insights out of it. For that, they have to ultimately generate a Power BI report or visualization or a dashboard. For that, again, Power BI is a separate service. Even though it was a SaaS service, it was not well integrated with the other analytical engines of Azure, which means we have to procure Power BI separately, install on-premises data gateways, and then expose these data through on-premises data gateways either via direct query or copy the data. For better performance, we have to copy the data into imported data models into Power BI, which the business users can use, can consume, can develop the reports and dashboards out of it and consume. And this Power BI is oftentimes exposed to all the business users across the organization, so they access it publicly, and it is secured via different mechanisms such as Entra access policies and stuff like that, right? So this is how we used to do security in the past world, right? Everything is a siloed product. Everything has to be independently procured and secured, and we have to make manual connections between all these services. And more importantly, the data is not uniform. We have to copy the data back and forth between each of these services to have an end-to-end integrated solution, right? Now, shifting focus to how we are going to do things in Fabric, right? That's a big paradigm shift. Now here, if you look at it, we have one product, which is you buy only one capacity, which is the Fabric capacity that has all the experiences, all these compute engines built into it. You don't have to individually procure anything. You just sign up and you create a Fabric capacity and you create Fabric workspace, and that's it. You are in. You can use any experience as you would like, right? That is, as a data pipeline developer or as an ETL developer, you can go ahead and create a data pipelines, connect to any of these 120 different data sources and bring the data into Microsoft Fabric. And once you bring the data into Microsoft Fabric and land it into the one lake, it is automatically made available to the other analytical engines. A Spark developer automatically gets to see the data in their lakehouse, and then they can start writing Spark notebooks to perform their transformations out of it. And as and when the Spark developer is performing transformations and modifying this data in their lakehouse, automatically the SQL developers are able to see that using their SQL endpoint and consume the data via SQL, perform SQL queries, and do their business analytics in SQL without having them to move or copy any single data here, right? And and just not that. The Power BI developers, the business users, or the self-serve business users get to see the data directly on the one day. And Power BI has now has the ability to create reports from the data that is stored in the one lake using direct lake mode. That is, you don't have to, without having to move or copy the data, we can create semantic models on top of it and create visualizations and dashboard as and when these Spark developers are doing transformations and the SQL developers are performing their transformations. The modified data is instantly accessible to the reports and dashboards without having them to move to any different tools or any different dashboards. In fact, they can do all this in a single workspace if they can, right? So this is a complete paradigm shift. And one important thing to note here about security is all these engines are completely managed by the Microsoft SaaS platform, meaning that all the communication, unlike the previous picture where we had to connect the data factory to the private endpoint of the storage, we have to connect the private endpoint of the storage to the Synapse, we have to connect the Synapse to the Power BI. There's a lot of interconnectivity that are required by the customer to manage, right? Here, all these connectivities are managed by Microsoft using our global backbone network, right? That is, the data factory is talking to the one lake with Microsoft network, right? You don't have to configure any private endpoints for that. It's automatically available. The data is in one lake, is private to the data factory, right? Similarly, the Spark clusters are able to seamlessly connect to the data in one lake securely and privately using Microsoft Global Backbone Network. We manage these networks for you. You don't have to bother about setting up these private endpoints between individual data sources and connecting them, unless you want to use the PaaS resources, right? If you are going to develop your entire solution in Fabric, all your data is going to live in one lake, and all these experiences are able to talk to each other and also talk to the underlying storage securely and privately using global Microsoft backbone network. And all you need to do is secure your incoming connections to Fabric. That is how your data engineers and business users and data developers and pipeline developers are going to authenticate and interact with the fabric. If that's all you need to secure. All the internal communications between the services are already secured by SaaS platforms. So that's why when we say SaaS, it is secure by default. And I'm going to explain a little bit about the backend architecture here, right? Because whenever we talk about security, it's important to understand some of the underlying architecture or how these things are working together, right? If oftentimes when I sit and talk with the customers, they say that, hey, I want to protect my backend services, right? I cannot expose my databases, I cannot expose my data in storage. These are the common themes that I get, right? Let's see what does the backend really here is, right? If you take any fabric item, right, it could be a pipeline that you're accessing, it could be a database, it could be a data warehouse, it could be a lakehouse, it could be a Power BI report. Regardless of whichever fabric item that you are accessing, every single request that is originating from the browser or any client application has to go to what we call as a web front end, right? The web front end is fabric.microsoft.com. If you go to fabric.microsoft.com, the request from the browser goes to the nearest Microsoft point of presence. Like for example, if I'm a user who is sitting in Switzerland trying to access Fabric, the request goes to the nearest Microsoft data center in Switzerland, and then from then on, the front end contents, which is the UI, the browser that are needed, the HTML and the JavaScripts that are needed to render my reports and my visualizations are served from the nearest point using the front end or the content delivery networks, right? This is just the front end content we are talking about. But then the actual data could reside in a different region. That's what we call a capacity region or the backend capacity, such as my backend capacity could be sitting in UK, perhaps, right? So it goes to the backend capacity platform region to perform all my computations, and that's where my workspace lives. That's where my data actually lives. That's where the computation happens. At the same time, the whole Microsoft Fabric is built on Microsoft Entra tenant, right? The tenant could be the Power BI home tenant, could be in a centralized region such as Western Europe, right? So that's where the metadata platform lives, which means this is where, okay, how many workspaces this organization has, who has access to what workspaces, and the information about this data, like what is contained in those workspaces and stuff like that. All the metadata, the ACLs, they live in the metadata platform, right? So we have two kind of backend platforms. Yes, one is the metadata platform that has information about the workspaces and the access controls and stuff like that, and we have the backend capacity platform, which has the actual data, which stores the actual data and which performs the actual compute. Right? These backend capacity platform, and the metadata platform are already running in a secured virtual networks. But these virtual networks or VNets are completely provisioned and managed by Microsoft, right? These are Microsoft global backbone virtual networks that are completely protected from the internet traffic, right? Nobody can willy-nilly from internet can come and access our backend servers. These are running in a secured VNet. What we do expose are secure endpoints to the web front end that can be securely routed to these backend cluster along with proper authentication context. Now, this is the key. Every single request that is coming into Fabric, that is accessing any item in Fabric, has to be authenticated and authorized by Microsoft Entra. We keep the Entra as the central security gate of all the requests that are coming into Fabric, right? This is key because unlike other PaaS databases or storage accounts, for example, you can create an Azure SQL database and you can have a SQL authentication for that SQL database. You can create a username and password kind of authentication that only that SQL server knows, and then you can get into the SQL database. Same thing when you create a storage account. There is an option for you to access the storage account using the account keys, or you can create SaaS tokens or SaaS URLs and go into the storage account directly, right? Yes, of course, you can protect by Entra. We have Entra integration with the PaaS services also, but that's optional. But here, Microsoft Fabric Entra integration is baked into the product from the get-go. Every user is signing into Fabric by signing into Entra, actually, right? So they have to sign in with their Microsoft organizational credentials in order for them to get to their data in Fabric, right? So the Entra is the central gatekeeper of all the incoming requests that are coming in, regardless of the tools that you're using, whether you are using a browser, whether you are using a client tool such as SQL Server Management Studio or Kusto Studio, etc., or if you're using APIs, regardless of whichever tools that you're using, it has to be authorized and validated using Microsoft Entra, and only then the web frontend will route the traffic to secure backend services using our secure endpoints. And all the transit, the data in transit is encrypted at least using minimum TLS 1.2 encryption, which is the industry standard encryption that we enforce for all endpoints in Fabric. And once the traffic reaches the nearest Microsoft point of presence, from then on, all the traffic between these Microsoft services and between these data centers, that is the traffic between these capacity platforms, traffic between these metadata platforms, traffic between Power BI to OneLake, Data Factory to OneLake, Spark to OneLake, all this internal traffics are going over the Microsoft global backbone network and not the public internet. This is one of the key objectives to learn, right? Because this is where most of the question comes. Hey, is my data traversing over the public internet or not, right? Like, so how is this flow working, right? So this is at the very high level backend architecture of these SaaS platforms or built, right? And by keeping the Microsoft Entra as the central gatekeeper, we can have integrations with all the other resources that Entra has connection to. For example, all your on-prem resources are also connected to Entra. All your devices, the corporate devices, the mobile devices that the users are using, are also connected to Microsoft Entra. The other clouds can also be connected and integrated with Microsoft Entra with authentication pass-throughs, right? And with this kind of integration, we can have a centralized place to secure and govern our data rather than securing individual databases and storage accounts and mucking around with the firewall rules and the private endpoints of every single place. We can have our central security and governance, our IT security, manage the security through Entra, and those policies can be centrally applied to all the other services, including Microsoft Fabric. So that's the advantage that we get with Entra integration, right? And when we talk about inbound protections, right, when we talk about how we can protect our incoming communications to Fabric, there are two different approaches here, right, that I would like to educate upon. One is the traditional or the perimeter network security approach. This is how we have been securing things for so long, right, in our organizations, right? If you have data that you want to protect in your organization, the traditional approach is to say, hey, you have to be in my office location in order to access my data asset. Either you have to come to physically to my office location and connect to my network, or you have to connect to my network through VPN tunnels, and then only you can access this data. So this relies heavily on appliance such as firewalls and VPN devices to protect your data assets by enforcing a physical network security boundary, right? That is another approach. This is good. This has been working for so long, but it has got some limitations also. It doesn't cater to the needs of the modern workforce, and it doesn't cater to the modern threat landscape also, right? Oftentimes the attacks, if I look at the if you look at all the major cyber attacks that are happening, the people can easily get access to a corporate network. All that they need is one vulnerable device or one vulnerable port or one single vulnerable application or a software that they need to find in a network in order to gain access to the network. Once they are into the network, then they can get lateral access to multiple resources in the corporate network because we are trusting our corporate network to be a securable boundary, right? So that is the fundamental flaw here, right? That is, for example, if you have one single Windows, older version of Windows running on a desktop, that's good enough for an attacker because that is connected to the internet, and that's good enough for an attacker to inject a malware, finding the vulnerability in that old operating system or old driver of the application to gain access to the network, and thereby attaining access to all your private resources within your network, right? So this is not enough for the modern security threat landscape. We need to do more, right? That's where the zero trust approach is coming into picture. What is the zero trust approach, right? Zero trust approach meaning like we don't necessarily trust the network security to be the secure boundary. We have to explicitly verify every single request that is coming in, whether it is coming in from our network or from outside network. It doesn't matter. Every single request has to be verified, and we have to use the concept of least privileges, right? We have to use least privilege access for every single request based on the access, and then we have to assume breach but within our own networks, right? So this is the concept of the zero trust approach. And when we look at Entra has several mechanisms to enforce this zero trust access mechanism, such as user-friendly multi-factor authentication, enforcing MFA for all the device logins that are happening to Microsoft Fabric. And you can also configure conditional access based on context and risk assessment, right? Talk more about what these conditional access are and what are the different kind of policies that you can set through Entra and enforce access to the protections to Fabric. And then you can also go advanced, such as you can use the user and entity behavior analytics, because Microsoft Entra is a global service, right? We are receiving about 1.1 billion logins every day. We can learn a lot from those logins about malicious users and malicious activities, and we can use that knowledge to our advantage. Meaning, like, if I'm a user, I usually log in from the East US region. Suddenly my identity is stolen, and then there is a suspicious activity happening in some other countries or the regions. Entra can automatically detect that because there is a behavior pattern, and because of this behavior pattern detections, it can alert the administrators to take corrective actions and immediately revoke my access or take other corrective actions, such as notifying the users of anomaly, right? So we can take advantage of these kind of advanced threat detection models that are baked into the product. Again, these are not specific to Microsoft Fabric, but Microsoft Fabric is tightly integrated with Entra so that we can take advantage of all this Entra-based security models to all the inbound connections that are coming into Microsoft Fabric. And that's what the conditional access policies play a central role in securing your Fabric estate here, right? Let's take an example here, right? I'm an healthcare organization, and I want to make sure that Fabric can be accessed only from my corporate network. My Fabric should not be available on the public internet, right? This is a common request. Hey, I don't want my database to be available on a public internet. I want to restrict access to my private network. How do I do that? We can do that without private endpoints. How? By using conditional access policies. Meaning, we can go craft a access policy in Entra saying that these are the set of users who are going to use Fabric. And for these users, make sure that the request is coming from this particular network location, such as your corporate network boundary with your data center IP addresses. You can whitelist them and say, these are my data center IP addresses. And if the request is originating from these data center IP addresses, only then trust them and let them in, right? If not, you challenge them. If not, you challenge them with multi-factor authentication, ask them to sign in again and stuff like that. We can do some advanced authentication checks if it is not coming from your known network location. And we can also go one step ahead and say device policies, meaning it's not enough if you are coming in from a network. If you are not coming in from the trusted my office network, make sure that the request is coming in from a corporate registered approved device, and make sure that the device is running the latest and greatest versions of the operating system. Make sure that the device has installed all the security patches, which are the main culprits of any malware attacks and cyber threats, right? We can ensure that every endpoint, that is every device that is accessing services such as Microsoft Fabric, are protected and compliant and registered to the corporate tenant by ensuring device access policies to be also in place, right? Without satisfying these conditions, that is, without being in the corporate network, without coming from the corporate approved registered laptop, a compliant device, I won't even be able to generate the token that is required for me to authenticate Fabric. It stopped right at the gate, right? This is the kind of policies that we can enforce from a central IT perspective without the application developers, without the business users, without the data engineers having to worry about network security and private endpoints and putting these things together. We can have a centralized IT security govern the policies for the use of your entire data estate in your corporate using Microsoft conditional access policies. This is the SaaSified way or the zero trust way of securing your Fabric connections. There is another method that Fabric supports, which is the private link connection, right? This is a very popular feature for PaaS services. For example, when you create a database, you can log down from the public internet and you can create a private endpoint for the database. Same thing with the storage. You create a storage account, you create a private endpoint for the storage account. But now we are talking about Fabric, which is available for all users in your organization, right? It's for enterprise data lake that we are talking about, right? Locking that down to a private endpoint is still possible. That is, you can lock down your entire Fabric tenant to a specific virtual network or a specific set of private endpoints so that, hey, if you want to access Fabric, you have to be on that virtual network and access can be granted only via those private endpoints that are talking to the Fabric tenant. Your entire Fabric tenant is disconnected from the public internet, right? You can access only from the on-prem via ExpressRoute or VPN, or you can access from VNets, Azure VNets that are peered to this VNet, right? This is a very restrictive network topology to access an enterprise corporate-wide analytical tool. Which so what that actually means, but it is supported today. It is generally available, and you can set it up at a tenant level. At a Fabric tenant, you can block public access and you can enable private link. But I'm telling you, this is not a very popular feature because of various because of the way in which the SaaS service are different from inherent PaaS services, right? What this means is the entire Fabric tenant is disconnected from the public internet, which means every single business user in your organization, not just data engineers and developers, every user who wants to consume report, every user who want to see a visualization has to go via your express routes and VPN and VNets and make sure that that route is um, traversed via this private endpoint to get to their data. This also means that, as I explained before, the web front end is operates out of a global public content delivery network, which means that the contents are delivered fast from the nearest point of locations, right? That is no longer possible because the private endpoints are residing in a specific region. So if you are a user in Switzerland trying to access a report in Ireland, the data has to transfer. It has to go to that particular data center and fetch all the UI elements as well, including the entire UI studio for you to render these reports, right? So there is a latency and there is also increased express route bandwidth. Now, we are not just talking about data developers accessing a database or a storage account here. We are talking about the entire business users accessing all your corporate reports and dashboards and stuff like that. So, which means that there is an increased traffic that you need to consider for your express routes, right? There are some other limitations, considerations also that you need to make, such as your on-premises data gateway will not work, and that the publish to Excel and publish to web is not available. Exporting the report to PDF will not work. Email subscriptions might not go out. There are so many other caveats that are inherent to SaaS products that, for a reason, we do not lock the SaaS products down to the private endpoints. But it is available if your use case demands such kind of a lockdown network. It is possible for you today to configure them, but it is not that popular. Um, that is, but this is, so far we talked about how to, how to secure the Fabric, the incoming connections to Fabric, what we call as an inbound security, platform security, right? But this is not the questions that I get most often from the customers. Most often the customers that are asking that, hey, I have my data, I have my existing data in siloed PaaS services or on-premises networks, which are behind firewalls and VPNs and private endpoints. How do Fabric connect to those private endpoints privately and securely and get the data to Fabric? This is the number one question that they ask. We have several methods today that are available for you to achieve this, right? Starting from the very left, you can use existing Azure PaaS services. If you're not ready to migrate your entire data pipelines to Fabric yet, let's say you have your pipelines in Azure Data Factory, you have your data ingestion frameworks in Azure Databricks or Azure Synapse. If you have your existing services, all these services have connectors to Fabric now, right? Azure Data Factory has Lakehouse connector and Warehouse connector. Databricks can connect to Fabric using the OneLake APIs, OneLake ABFSS endpoints. Same thing with the Synapse Spark. So we can use this existing frameworks and pipelines. You don't have to move your ETL to Fabric. You can use your existing ETL frameworks and pipelines to move your data as an additional data destination to Fabric securely and privately. One thing to note that I would like to educate in this session is any Microsoft services, the traffic between these Microsoft services. Let's say you spin up a virtual machine in Azure in East US data center, right? And you spin up a Fabric capacity in the same East US data center. Remember, Fabric is also powered by Azure behind the scenes because Fabric is one of the Azure core online services. If you look at our terms and agreements, when you are buying a Fabric's capacity, it's clearly mentioned that Fabric is one of the Azure core online services, which means that the Fabric is powered by the same Azure East US data center that this VM is getting powered, right? So both these computes and the storage are in the same data center, right? And when you transfer data from one Microsoft service to another Microsoft service, the data never leaves the Microsoft global backbone network. We do not use public internet between the communications for Microsoft services. We have clearly documented this in our documentations, and also we have published Fabric security white papers that talks about how we handle this traffic between the services and how we are using global backbone network for this, how this traffic is encrypted inherently, etc. Right? So the traffic is never going via public internet. When you transfer data from ADF to Lakehouse, from Azure Databricks that are running in Azure data centers to Lakehouse, when you're transferring data from Synapse Spark that are running in Azure data centers to Lakehouse, the data never, in fact, in most cases, the data never even leaves the regional boundary, right? Because you can have the capacity and the compute in the same region, right? So it's global backbone network within region. It's private communication, in fact, right? The second, there are many other tools that are available in Fabric that has the ability for you to develop your pipelines, develop your data integration frameworks in Fabric, and have the ability to connect to your data behind firewalls and private endpoints. We have Fabric pipelines now, right? Same thing with the data factory. We have copy activity in Fabric, which is very useful for transferring large volumes, gigabytes and petabytes of data into Microsoft Fabric using copy activity. We support something called as an on-premises data gateway. Again, these are the same on-prem data gateway clusters that people are already using for their Power BI. It's not a new product. We have enhanced the same product to support the copy activities now, right? The same on-prem data gateway clusters that are refreshing the Power BI datasets can now be used to connect to the secure data sources such as on-prem data sources or other cloud data sources and transfer the data securely and privately to Microsoft Fabric. And we have Data Flows Gen 2. This is the tool that is used by business users for lean and mean data transfers and also for performing ad hoc data transformations on the fly for ETL tool. We have on-prem data gateway support and VNet data gateway support, which is the PaaS version of it, right? You don't even have to install a data gateway on a VM. You just have to provision a virtual network and delegate a subnet for Fabric, right? We take care of that internal communication between Fabric and the VNet, and you can peer that VNet to any of your existing virtual networks or to your on-prem using express routes and transfer the data securely and privately to Microsoft Fabric using Data Flows Gen 2. That's another option, right? Let's say if you are a pro developer, you want to write all your data ingestions using Spark, right? Then we have an excellent Spark engine in Fabric, which is the Fabric Spark. And this has the advantage of managed private endpoints, which means that these Spark clusters are provisioned and run in a dedicated virtual networks called managed virtual networks that you don't provision and manage. We provision and manage it for you, right? So that you can create a managed private endpoint from the Spark clusters to any of the Azure resources. Let's say you want to copy data from Azure SQL database, you want to copy data from Azure Cosmos DB, you want to copy data from Azure Functions or any of these Azure resources. You want to securely connect to Spark notebooks. You can create a private endpoint to that particular resource and have a direct connectivity to that resource and pull data into Fabric using Spark. If you are developing an ingestion frameworks in Spark, that's an option for you. But the last option, which is the cool option, is shortcuts. Let's say you have your data already sitting in your storage accounts. You don't have to copy the data at all to Fabric. Without having you to copy the data, by keeping the data in place, we can create shortcuts to those existing data sources and have any of the Fabric compute engine, such as Spark engine, SQL engine, Power BI engine, can consume the data over shortcuts, right? We have shortcuts for Azure Data Lake Storage. We have shortcuts for Amazon S3. We have shortcuts for GCS buckets. We even have shortcuts for on-prem S3 compatible data, right? And these shortcuts are interesting because when it comes to shortcuts, we have something called as trusted workspace access, right? Let's say you have your ADLS accounts, which is the Azure Data Lake Storage account, where you have all your data lake tables, which are already brought in and processed by some other engines that now you want to simply consume in Fabric, right? You can simply do that by creating a shortcut. You can go ahead and disable the public network access of ADLS, right? You can disable public access to ADLS and you can create a trusted workspace access. You can take a particular Fabric workspace and create an identity for it called workspace identity and assign that identity saying that, okay, you can go to the ADLS and say only this particular Fabric workspace identity can access my data in ADLS. You can create a rule like that. And once you create that rule, it's called the trusted workspace access exception. Only that particular Fabric workspace will be able to access the data via shortcuts to that ADLS. And for all other communications, you can go ahead and disable the public network access to the ADLS. We are using the underlying Microsoft Global Backbone Network. Again, ADLS is owned by Microsoft First Party Service. Fabric is a Microsoft First Party Service. We are using the Microsoft Global Backbone Network for all of our communications without using the public endpoints at all, right? So that is possible today. So far, these managed private endpoints and the trusted workspace access were locked down to higher queues such as F64 queues. Not anymore, right? The good news is now these managed private endpoints, the trusted workspace access, on-premises data gateways, VNet data gateways, regardless of whichever solution that you're going to go with, it is available to all Fabric's F SKUs, right? Starting from F2 to F3 to F4, whichever SKU that you select, it's available now. It's not only limited to F64, right? And same thing with if your data is sitting in other clouds such as S3 buckets or GCS buckets or on-prem, you can create shortcuts using on-premises data gateways, which are the same on-prem data gateways that you're using for Power BI, can now also be used for shortcuts to securely connect to your existing data and consume the data in Fabric by keeping the data wherever it is, right? So these are the various techniques that we have to connect to your data securely and privately and bring the data to Fabric and perform the analytics on top of it, right? Uh, I think most of the people are data analytics folks, right? So that's why it is important to understand some of the platform security, like how that's why we talked about conditional access, how you can have a centralized governance for your network security. What are the different ways of connecting to your data using private endpoints, on-prem data gateways, VNet data gateways, etc. But the core concept here is data access control. Once I am into the Fabric, what about the RBAC? What about the role-based access controls? What kind of who can see what data in Fabric? How do I control that? We have very sophisticated mechanisms to do that today, right? Starting from the platform, we have all this platform level authentication layer controls that we talked about earlier. And then we have the concept of domains. Domains itself is you can create different security groups or AD groups for domain and assign those users to those specific domains, right? And you can delegate some of the tenant settings to domain admins for them to configure some of these settings, right? And going down from the domain, we have the concept of workspace here, right? Workspace is a critical concept in Fabric. It's unlike other Synapse. It's not a heavy-duty component. You can have as many workspaces as you want in Fabric. You can have hundreds of workspaces. You can have thousands of workspaces in a Fabric internet, right? A workspace is nothing but a securable boundary in Fabric, right? A workspace can have you can imagine a workspace just like a folder in a Windows. In fact, we represent the workspace as a folder in a one-lake Explorer, actually, right? If you look at a folder, there are different contents in the folder, right? Different types of files that can be that we can have in a folder, right? We have two types of permissions in a folder. One is read write permissions, that is, you can go and read the contents and modify the contents. The other one is read only permission, that is, you can go into the folder and look at the files, but you cannot modify the files, right? So those are the two different set of permissions. These permissions in the workspace are translated into four different roles: admin, member, and contributor. These three roles are read write roles. You can read the contents and modify the contents, but we have a viewer role in the workspace so that you can see all the contents in the workspace, but they cannot modify. It's view only. We can go further down. Let's say you don't even have to admit a user into the viewer role into the workspace at all. They don't even have to see the contents of the workspace. They want to get access to a specific lake house or a specific warehouse or a specific item report or dataset model in that semantic model in that workspace. We can do that. It's called item level access. I can share a particular item to a set of users and hey, okay, you can see only this particular lakehouse in my workspace. So we have workspace level controls and we have item level controls. Within the item, right? Let's say within a lakehouse, we can grant granular access permissions to folders in a lakehouse. Okay, you can have access to this lakehouse, but only to the specific folders that are accessible, or only to specific tables, or only to specific schemas. We can define access at folder level and schema level and table level in the one lake. This is called one lake data access roles, right? If you define these access roles in the one lake, any engine that is going to consume the data from the one lake has to honor this permission, right? Um, so that is what the item level access controls are. But we can have more. We can have more granular access controls by specifying compute level security. Remember, every single Fabric item has to be consumed by some form of compute. If it is a lakehouse or a warehouse, it can be consumed by SQL engine. If it is a semantic model, it should be consumed by a Power BI engine. If it is a KQL database, it should become consumed by a Kusto engine, right? There is always an engine, a compute engine to consume your item, right? For that compute engine, every single compute engine in Fabric has got its own security model, meaning you create a lakehouse or a warehouse, uh, you can define granular security such that, okay, whoever is consuming this data using SQL, they should see only these set of tables. They should see only these columns. They should see only these rows in a table. These columns should be masked. It's called dynamic data masking. So we have OLS, table level control, CLS, column level control. We have RLS, row level security. We have DDM, dynamic data masking. All the security features, and also you can have select, grant, deny kind of permissions that you can granularly define your policies in the SQL layer, right? This is for the SQL consumers. If you are going to consume the data using Power BI, then you will be configuring your security in the semantic model. There you can go granular security too. You can define RLS in the semantic model. You can define multiple different rules inside the model to see who can see which sections of the reports, etc. Right? That's all possible. Same thing, we can have granular controls in the KQL database also if you're using consuming Kusto. So every single compute engine of Fabric comes with its own granular security layer that we can further tighten the security of who can see what data inside a Fabric workspace, right? So to sum it all, right, we have Fabric workspace level permissions and we have Fabric item level permissions that are governed at individual items. And within each item, within the Fabric lakehouse, we can have table level permissions and folder level permissions using one lake data access policies, right? Once you set these one lake data access policies for specific tables and specific folders, if you are accessing this one lake via APIs, it will honor that. If you are accessing, if somebody creates a Spark notebook, okay, I'm going to grant only table 1 and folder 2 to one of my security role, right? And then I share that particular lakehouse with that particular user in security role 2. When they open a Spark notebook in their workspace, from any workspace in Fabric, from any capacity, if they open a Spark notebook and try to connect to this lakehouse, they will see only this table in this folder in that notebook. Similarly, if they try to access this lakehouse using any API, such as OneLake APIs or endpoints, they will get to see only those tables and folders that they are supposed to see, right? So this is how this lake house security works. Same thing, you are all familiar with the SQL security and Power BI security, because that already exists in the existing PaaS engines that we have replicated here in Fabric too. Same thing with the warehouse. You can go to a warehouse and define table level permissions and column level permissions and row level permissions, and any user who is using the endpoint, the warehouse SQL endpoint, we have to honor that. Same thing with semantic model. You can define semantic model level security, and the Power BI reports will honor that, right? So I'm putting together like an end-to-end scenario here. Okay, how to build a medallion architecture, a secure medallion architecture with Fabric, right? Let's say you have bronze, silver, and gold workspaces. Let's say you have your bronze workspace. This is where you're going to land the data from multiple different sources, right? So typically the data engineers or the pipeline developers, those are the people who want access to the bronze workspace. So you control the access to the bronze workspace using the workspace permissions, right? You lock down that particular workspace, right, to only those particular users. They will be the members and the contributors because they can read write contents in that workspace. Other users are not even part of that workspace. They cannot see the bronze data at all, right? Because it's raw data, right? The data engineers will be developing pipelines and notebooks to bring the data and build their lake houses. Now, this is bronze. Now there is a silver workspace. From the silver workspace, they need to do standardizations and further processing, refinement. Those are also data engineers who are going to access the bronze workspace in the silver workspace. They get their own workspace. They have members and the contributor permissions on that silver workspace. But to access the data from bronze workspace, they can get specific lakehouse only permission. Like they can share only a particular lakehouse to that data engineers, so that they won't get to see the pipelines in the bronze workspace. They cannot go and modify the raw data pipelines, but they get to see only the lakehouse that they have access to, right? From that, they can go and build further lakehouses using their Spark or pipelines or whichever compute that they prefer. And then the gold workspace. That's where our final semantic models, the Power BI models, and the data warehouses, the facts and the dimensions are going to live, right? For this, again, the data engineers who are going to work on the gold workspace will get the member and the contributor access in that particular workspace. But when it comes to accessing the data from the silver workspace, we can have one lake data access roles, meaning you have your one department, the HR department can only see the HR specific tables and folders in the lakehouse. The finance department can only see the finance specific tables and folders in the lakehouse. We can have one lake data access policies defined on that lakehouse, and these data engineers will be able to develop Spark notebooks to perform transformations, but only on those tables and files and folders. Right? They get direct access to the tables and files and folders in the Delta, but only to the specific list of tables and folders that they have access to. With that, they built a lakehouse, right? Once they build that lakehouse, it can be consumed in two different ways, right? It can be consumed as a semantic model for Power BI users. It can also be consumed as a SQL endpoint for the business analyst who want to write SQL queries on top of it. These we call the end users or the consumers of this data. They don't even have to be part of the gold workspace at all. You don't have to allow them into the workspace roles. They will not get to see any of the pipelines or Spark notebooks in your gold workspace. They cannot go and modify that. They won't be able to control that. But they can consume the semantic model using the RLS security that are defined in that semantic model using direct link mode, right? Same thing, we can create another lakehouse and create shortcuts to that existing lakehouse, right? And then we can define SQL security on that lakehouse, the second lakehouse. We are not actually physically moving the data. We are just creating another lakehouse and a shortcut. With that lakehouse, we can define SQL security on top of it and allow access to the SQL users, so that if you're coming in as a SQL user to perform your SQL queries, you get the same security. And then if you're coming in as a Power BI user to develop your reports and dashboards, you get the security defined in the semantic model, right? In both cases, the end users get to see only the data that what they have to see in that particular compute engines through granular compute engine permissions, right? Um, so with this, we are coming at the top of the hour. Um, the one thing that I want to touch is the encryption, because this is, we know, as we said in the earlier slides, that all the data in Fabric, all the endpoints that we expose in Fabric, we enforce TLS 1.2 encryption, that is encryption in transit. That applies to all the endpoints, XML endpoints, TDS endpoints, OneLake endpoints, APIs, regardless of whichever endpoints that you're coming from. TLS 1.2 is upright. The data is encrypted in transit, and all internal communications are also encrypted in transit. Because it's a SaaS service, we take care of that. And all the data that we store, that we persist, is encrypted at rest using platform managed keys. And our keys are compliant, right? Our keys are kind of like, we rotate and manage those keys. We take care of the compliance and certifications for those keys, etc., right? And as of now, we have so many great certifications already lined up. We are GDPR compliant, we are EUDB compliant, we have ISO certifications, various ISO certifications for tenant protections. We have IPA compliance for healthcare customers, and we also have SOX compliance, like SOC 1 and SOC 2 controls. And very soon we are going to have FedRAMP as well. All our services are compliant, and with a peace of mind, you can use our keys to encrypt your data and secure your data in Fabric with the various security features that we saw. I hope you all had a wonderful learning experience in this session. If you have any questions, or if you want to connect with me more to discuss the topic of security in Fabric, I'm happy to help. My name is Vengatesh Parasuraman, and you can find me on LinkedIn. I work at Microsoft in the Microsoft Fabric product team, and happy to connect and have a conversation with all of you. Thank you so much. Thanks for your time.